a high concentration of sodium. So there's a high concentration of sodium in the groundwater, then there's likely a high concentration of fluoride in the groundwater, with everything else being equal. So, okay. So my prediction would be if rain is what dissolves the fluoride-bearing minerals, then I feel like they're gonna try to say something like rain also dissolves sodium minerals, whatever.
Yeah,
Something.
like my question is, so if I asked you, why are the concentrations in groundwater significantly higher in areas where the groundwater also contains high concentrations of sodium? What would you say to that?
Um, mm, because the minerals in the soil have fluoride and sodium in them.
Mm-hmm.
And so when the
Yeah.
rain,
I literally, when I did this question originally, I had to like think about this. I'm like, okay, so like the fluoride enters the groundwater when rain dissolves these minerals right into the soil.
Mhm.
And so somehow it goes from the soil to the groundwater, right?
Yeah.
And then we have this study that shows that when rainfall, concentrations of these minerals and other relevant variables are held constant. So um, the fluoride concentrations in groundwater are significantly higher in areas where the groundwater also contains high concentrations of sodium. Um, so I guess what I was thinking was, actually, we'll go to the answers first before I say what I was thinking. Okay,
Okay.
so what kind of question is this?
Um, this is a must be true.
Awesome. All right, so go ahead and walk me through these answer choices and tell me what you think.
Okay, fluoride-bearing minerals are not the primary source of fluoride found in groundwater. We don't know that.
Correct. And primary is such a strong word. So if I was
Yeah,
going quickly, I'd be like, oh, we don't know it's the primary.
yeah. B, rainfall does not affect fluoride concentrations in groundwater. Um, that's not true.
Right, and does not affect, that's so strong. Like no effect at all. Like,
Yeah. Sodium-bearing minerals dissolve at a faster rate. We don't know that either. Sodium in groundwater increases the rate at which fluoride-bearing minerals dissolve. We don't know that.
okay,
Right?
this is where it gets really hard. D is actually the right answer.
Okay. But how do we know that that's what increases the rate? It just says that
Because it tells us that all other relevant variables are held constant. So it's the only thing that's different.
hmm,
So if nothing else changes and this is the only thing that's different,
hmm,
and so I agree with you that I consider these must be true questions, but technically it's a most strongly supported question because it says most reasonably. And
mhm,
most strongly supported, they say, is kind of like 90% guaranteed, where must be true is 100%.
mhm.
But I still approach them the same way. So I wasn't going to correct you on that by any means.
Mhm.
But here, if everything else is held constant and this is the only thing that's different, can't we assume that the sodium is what's causing it?
Yeah, I think. Okay,
Or
yeah,
is it reasonable, I should say?
yeah,
Since it's asking, is it reasonable?
yeah, okay, I can see that. What about E? Um, so that contains high concentrations of sodium-bearing minerals also contain. Oh yeah, and that was what I picked. I picked E.
I don't think we don't know where it comes from. Like, we don't mention sodium-bearing minerals at all, do we?
Mm, I guess it just assumed that,
That sodium comes from sodium-bearing minerals?
yeah,
I would say
like,
that's probably a stretch.
mm,
Maybe the sodium comes from, I don't know, like a fish. I have no idea.
true. Okay, I could see
That's a
that.
hard question for the first 12.
Yeah,
Um, so this is one where I would have crossed the first three off pretty easily.
yeah,
I was thinking that's what I was gonna ask you is like what do we know about this then? That was what I was trying to get at is like the other things held constant.
yeah.
Like if this is the only thing that's changing.
Hmm.
Um, but on this one, I think narrowing it down to D and E is probably what most people do.
Hmm.
And so how do we cross E off? Um, honestly, it's just really paying attention to like we do not know where the sodium comes from.
Okay.
That's the only thing that really makes that wrong because if that wasn't the case, then it kind of goes back to well, that's the only thing that's different between the two things.
But we can say that we know that the rate is affected because it said all other variables are held constant.
Yes, like nothing else changed except that whenever the fluoride concentrations are significantly higher in areas where the groundwater also contains like it pretty much when like fluoride, we're saying the fluoride in the groundwater is higher when the groundwater also has high concentrations of sodium. It's that's the only thing that's different.
Hmm. Okay.
So it's saying like there's a direct correlation there.
Okay.
I feel like they don't give us questions like that very often, where like normally we have to say like, no, correlation doesn't equal causation.
Yeah. Yeah, exactly. Exactly. Like I mean, I guess it is they're talking about rate not causing, but